Good afternoon, everybody. Oh, somebody's clapping already. This was like the easiest audience ever. And good afternoon to those of you out in Zoom land. I know that we have some family from today's event watching. I also was told that some of our previous emerging leaders are online, so if so, welcome. For the potential folks out there or new family members here who don't know, I'm Aaron Bobick. I'm the Dean of McKelvey School of Engineering and Professor in Computer Science, and it is just my honor to be here today. This is actually still a relatively new event. This is our third annual McKelvey Engineering Emerging Leaders Award. And it's a different approach than we've had an Alumni Achievement Award for a very long time. It's fair to say that most of those folks have been out for far longer than most of you folks. So it was really good to be able to highlight the accomplishments of people who are really stepping up. As an engineering school, we produce all sorts of things. We produce knowledge, of course. I'll talk a little bit about that in a little while. But we also produce people. And you know, when you tell someone on an airplane that you're from a university or a professor, you know, the first thing they ask you is, you know, what do you teach? And then if you're like me, you say, you know, as little as possible. Because, you know, a lot of us are very involved in research. But fundamentally, our core mission is of research and education. And our product of education really is our people. And today we get to celebrate some of our people who are, as I say, emerging leaders, people who are taking everything that they've absorbed to this point and figuring out how to go out and make an impact. And that's who we celebrate today. This year's honorees have achieved success as engineers through applying their skill, everything from renewable energy systems, space exploration, investigative research, healthcare operations, and overall approach to global engineering projects. Today, and I want to make sure I get all these names right? So last year we had much harder names, so this is easier. Frank Bergh. Actually, why don't you just wave to everybody so they'll know who you are. Craig Goergen. Okay. Kate Nevin. And Fiona Turett. Really all exhibit this dedication to excellence and to sort of WashU's meaningful commitment to developing folks to help make a difference. And we look forward to recognizing their success today. Often I'll take this opportunity to give a quick update on the state of the school. So, you know, the standard line is the state of the school is good. But the state of the school actually is not good. It's great. We continue to grow in every dimension that you can imagine. Except overall total number of undergraduates. That's been sort of at a plateau, and it's one that we push to. We actually have backdoor ways of growing that number, dual degrees and a variety of others, but we're somewhere on the order of 18% of the university, and that's where WashU as a comprehensive university is. But in every other dimension, we continue to grow the number of graduate students. So back when all of you were undergraduates, we had on the order of 300, 330 PhD students. We now have 560 PhD students. And of course, PhDs are really how you get a bunch of your research done, so that increases overall strength. Not that long ago, our research awards were on the order of $25 million a year. I think, Natalie keeps telling me, for the first time ever, we'll crack $50 million. Which would be a great thing. We continue to grow the faculty, both in number and in areas. I made a quick list here of just some of the key areas. A lot of work on biomolecular cellular engineering, a new center for biomolecular condensates, a new center for women's health engineering, a bunch of efforts on the engineering brain science, which connects a lot to an imaging science program, which we launched a couple of years ago, which continues to thrive. The university's strategic plan is out. I encourage you to all take a look at it. It's called Here and Next, and you'll see that environmental efforts are a big deal, and leading that is McKelvey Engineering. And Dan Giamar, one of our faculty, is in fact the lead. Focus here on aerosols, water, planetary health. We just were able to liberate a rock star faculty member from another university, from a top 10 chemical engineering department actually, to come here who does work on decarbonization. from energy processes. And then over in computation, a lot of work on trustworthy AI and cyber-physical systems. And so these are a bunch of the areas that are sort of new and emerging, if you will. So that goes well. You know, our finances are as good as they can be. For those of you who are thinking about where you should share your philanthropy, we're always very appreciative. All right. So let's begin the awards ceremony. As I said, these emerging leaders are focused on, you know, it's not just canonical engineering. In fact, I'm always impressed when we do our Alumni Achievement Awards, people taking a long career. People start out in engineering and then sort of take an evolution in who they are and what they do. And a lot of that happens because they gain deeper understanding of the problems that matter and the skills that they bring to them. And often it's not doing the fundamental hardcore engineering, it is helping others figure out what engineering needs to get done, what questions need to get asked. You know, I always tell people that in engineering what we do is we teach people that there's no problem you can't solve if you're just willing to take the time to think about what the options are, decompose it into a set of possibilities, and then you have to have the courage and the will to go after them. And I think that's one of the common things amongst our emerging leaders. I also want to take a moment to recognize, because I think some of them are online, just as we started, last year's honorees. So if you're out there, Christine Hansen, Melissa Holtmeyer-Terlahi, Jennifer Pangborn-Gold, and John Schubach. Remember, I told you the names was a little harder. Actually, join me in giving them a recognition. That group, along with the group, the inaugural group the year before, and this group today really helps us set the standard. Let me begin with our first honoree. At McKelvey Engineering, we often talk about that what we do is try to do work across disciplines and across the world. And our first honoree, Frank Bergh, fulfills this statement wholeheartedly. As an accomplished business owner, electrical engineer, and humanitarian, he holds a passion for social justice and sustainability. In his role as senior electrical engineer with the National Rural Electric Cooperative Association International, Frank works with rural communities in developing countries to change the lives of those getting electricity, or in developing countries to change the lives of those getting electricity for the very first time. And you know, it's easy to read today about AI and all the remarkable stuff going on. And we have people in the world who are getting electricity for the first time. And to remember that span, that's something that is important to do at a place like WashU. As a student, Frank made a lasting impact on the university when he founded the WashU chapter of Engineers Without Borders, and he remains dedicated to the university by supporting student scholarships, the students who go on to do this great work.
My name is Frank Bergh. I graduated from Washington University in 2008 with a bachelor's degree in electrical engineering. I came to WashU because after I visited the campus, I really fell in love with the place, and I really appreciated all that WashU had to offer. The university was an excellent place. They won me over with an engineering student visit, and I was committed after that. Engineering is a people-serving profession. Engineering is about improving the quality of life for real people with real stories and real problems. One of the things I'm most proud of from my time at WashU was starting the Engineers Without Borders chapter and the opportunity to really connect my coursework to the real world. So no longer was it about math, science, prerequisites, and problem sets. It was about clean water, clean energy, and really changing the world. In addition to that, I was on the baseball team, I was an RA. I represented the engineering school in the Student Union Senate for 3 of my 4 years at WashU. And it was those opportunities that really helped to connect me to the campus and really helped me to expand what I was learning in the engineering school. My current role as a senior engineer for NRECA International, my role is to increase energy access and rural electrification around the world and to address the 700 million people in the world who don't currently have access to electricity. My WashU engineering education is very relevant to the work that I do with NRECA International. I found that throughout my career that The engineering program at WashU, because of teamwork and interdisciplinary studies, really emphasized in me the ability to be a good technical communicator. My achievements as a professional would not be possible without my wife and her support, and my son and the family that we have together is incredibly exciting and important to the work that I do. It also gives me an opportunity to relate to the families that I'm working with. You know, families in rural areas should not be worse off than families that grew up in the U.S. or families that have WashU degrees. You know, where we live should not determine the quality of our electricity or the quality of our lives. Being a scholarship recipient is the reason I went to WashU. WashU was one of many choices I had as entering undergrad. It was really important to me to be a scholarship recipient and to have the university and its donors invest in me. For the students entering McKelvey School, I would have a pretty significant challenge to you, which is not only to find a way to get your homework done, but to find the way that your homework is going to impact the world, and the skills that you're learning here at WashU have the potential to make a tremendous impact. When I got that call from Dean Bobick about this award, I was thrilled. It really was not expected, but what it does is it helps to affirm that my time at WashU was well spent, and my time since then, although not a conventional engineering path, translating a WashU electrical engineering degree into global humanitarian work, that is recognized by the university. That is a pursuit that the university is in some way proud of, because I'm certainly proud of my affiliation with WashU.
Frank, thank you for the impact you've had, not on WashU, but in the world. I do want to point out there's some proud folks in the back. December, can you wave? There's Frank's wife. Was that cool? That was cool. Greg. And it's Goergen, right? Greg Goergen. Thank you. Craig has combined advanced engineering, imaging, and biological approaches to study cardiac disease while educating the next generation of students, because Craig is an associate professor at Purdue University. His research focuses on improving cardiovascular disease diagnosis, treatment, and prevention with the hopes to provide patients with longer and more fulfilling lives. Craig is no stranger to hard work and commitment. As a prestigious Danforth and Woodward Scholar, he graduated, valedictorian of his class. Craig managed to accomplish this while staying involved as both a varsity athlete on the swim team and a member of Kappa Sigma.
When I was looking at colleges, I explored lots of different options and got to see several different campuses, but there was just something magical about campus and WashU itself that really struck me. I received a half-tuition merit-based scholarship, the Woodward Scholarship, to attend Washington University. This was a huge financial help for me and my family, and helped make attending Washington University possible for us. My undergraduate training at Washington University was a fantastic primer for graduate work, graduate research. It helped me understand the biology, the medicine, but also the engineering fundamentals, the math and the physics, so that when I was taking courses in all these different areas, I felt prepared enough to move on to that next level. The Bachelor's of Science in BME at WashU was a fantastic leg up to start that program. So at Washington University, I was on the swimming and diving team. I was a springboard diver, and it was a fantastic experience. It really helped with time management skills. There was a lot of time in the pool and practice and meets. It gave me a chance to interact with people outside of my own major and meet both men and women from different varieties, backgrounds, and interests. And go to meets and compete and see other people from different universities. I began at Purdue University in the Weldon School of Biomedical Engineering at the very end of 2012. I started as an assistant professor and then was promoted to an associate professor in 2019. I was named the Leslie A. Geddes Associate Professor of Biomedical Engineering. I also started as Director of Clinical Programs. I help our faculty and students connect with academic medical centers on projects where our technology that we're developing can be applied then to patients. For example, in the heart, we want to understand what happens as it changes after an injury. So what we've done is used ultrasounds to create a picture of the heart not just in one specific frame, but from the whole part, from the top to the bottom of it, so that we can see how it's moving and functioning, and then how that progresses as it's undergoing a disease or certain pathology. And so it's really rewarding to see some of the things we're working on in the bench here make it to the bedside, make it to the patient, and have an impact. I would tell any other incoming first-year engineering student at WashU that it's great to take risks, meet new people, and try new things. This is the time in your life where you can try and do different things that you've not had experience with, and WashU will provide a lot of opportunities and capabilities that you might not have had access to previously. So take those opportunities and run with them. It's a great honor to receive the McKelvey Engineering Emerging Leader Award amongst this amazing group. The faculty and students at the McKelvey School are incredible, and the alumni that have come from that program are even more impressive. So it's a wonderful group to be part of, and it's a great honor to be part of this Emerging Leader Award.
Craig, thank you for your dedication to the school and to research. I was told all the little kids were sitting up back because they didn't want to make a fuss. I think they should sit up front. Are you gonna wave? Hi.
Are you serious?
Okay, I'm sorry. Yes. Our next honoree, Kate Nevin, is passionate about data-driven decision-making and applying engineering principles to solve complex operational problems. Her education as a mechanical engineer has presented a diverse path, which led her to MIT Lincoln Lab, then to MakerBot, and now at Mount Sinai Health System. Her work was integral in helping New York City's largest health systems develop an operational response to COVID-19 pandemic. It's not written here because it's not known. A very good friend of mine, Meg Rosenblatt, was the head of anesthesiology efforts at Mount Sinai during the pandemic, and it was remarkable what you all put together, and it was really something. While she was at WashU, Kate was an active member of SWE, Society of Women Engineers student organization, and the Alpha Epsilon Phi sorority.
I am the youngest of three. My dad is the one that really encouraged me to be an engineer, and my dad was the one that really kind of put that idea in my head of, this is a thing you can do. When I started at WashU, I actually was in the engineering school, but I was undecided. After probably about a year, I realized that I was more into the mechanical side of things. Dr. Bailey was, without a doubt, my biggest mentor. He was my advisor for my bachelor's as well as my master's, and he was the one actually that really encouraged me to pursue the research track for my master's, and I worked in his lab with his team. He's continued to be a mentor for me. I was pretty involved in Society of Women Engineers, which is a great way for me to make some friends who were also engineers. And I was also very involved in my sorority, A5. That was also really important to me because it allowed me to make friends who were not, for the most part, were not engineers. The friends I made there are still super, super close with my roommates and all of my best friends. I am the Director of Health System Operations at Mount Sinai Health System. Our team is really responsible for helping to execute on the health system's strategic visions, really on optimizing our operations. My team in particular is focused on data analytics, and so we develop tools that allow senior leaders within our health system to make data-driven decisions. This could be something around what is turnaround time for labs and how does it differ across sites, and is there anything we can do to standardize that? My greatest professional source of pride, there are probably two things. The first was when the project that I worked on at Lincoln Lab actually launched into orbit. The other thing I would say that's been a great source of pride is working for Mount Sinai these last couple of years, especially during COVID. Our team was able to really help the important decision makers make the decisions they needed to make. Being a female engineer it's certainly challenging. You have to learn negotiation skills and skills of persuasion pretty early on, which I also think just helps you become a more confident engineer. The impact I'd like to have on McKelvey engineering is, I'd like to be a role model for engineering students or young engineers entering the workforce, especially females. I hope to be someone that people can see and find balance in being a successful engineer, but also being in a successful relationship and raising kids. It's very humbling, but also a great honor to be given this award. I want to thank my parents for encouraging me to be an engineer and supporting me throughout really every phase of my life. I want to thank my husband, Simone, for being incredibly supportive, encouraging me to always keep growing.
Kate. Thank you. Done. I want to say before we go on to another woman engineer, just this past summer, we hired our first full-time director for our Women in Engineering Center. And it is really focused on this idea that there are challenges and ways of dealing with those challenges to help support and increase the experience of our women engineering students. And for those of you who are new to us this year, I'm pleased to say that the incoming first-year class of this past fall, 41% of the incoming class identified as women, which I think is pretty good. Yeah, that's really good. Our final emerging leader, talking about space and things launching into orbit, started her career with NASA actually shortly after graduating from WashU in 2009. And then probably felt like a long time, but actually in space years is a pretty short time. In 2021, achieved a career milestone when she earned her spot as flight director at the Johnson Space Center. For over 60 years and more than 230 missions, teams of dedicated engineers and specialists have provided ground support for astronauts in space and on the moon. And Fiona now oversees the human spaceflight operation at NASA's Mission Control. I don't know about you, but there are those of us of a certain generation for whom Mission Control was the second coolest place to be. The coolest place to be was on the rocket. But Mission Control was way safer. But it was indelible in our minds. From what I now understand, Fiona chose Mosaic Flight as her call sign, a metaphor for how every individual in Mission Control comes together, a collaborative element that will certainly benefit all of humankind.
I first wanted to work for NASA in middle school. I did a project about the solar system and decided I should be an astrophysicist, and then I learned what that was, and I thought maybe I'll be an engineer instead. What I loved most about WashU was that every single person I met was super passionate about something, but it wasn't all the same thing, and so I could learn a lot and have some really interesting conversations with my roommates and my floor mates and my friends who were not in engineering, and just hearing them talk about what they were passionate about and what they were studying was super cool. As an undergraduate at WashU, I was able to work on a small satellite through the Aerospace Systems Lab, and I think that was very influential and impactful for me. It did allow me to go to conferences and meet a lot of different people in the industry, and it helped me learn a lot about kind of the life cycle of a project, some project management and presentation skills, as well as the technical skills, and I definitely use a lot of that same knowledge in what I do today. I started my career here at NASA in 2009, right after I graduated from WashU, At that time, I was working in propulsion system safety. And after doing that for the last 2 years of the Space Shuttle program, I took a year off and volunteered in Central America. I taught English and tutored middle school math and literacy, and then ran a child sponsorship program through a nonprofit. And then I came back here and started working here in this room at Mission Control as an ADCO, which stands for Attitude, Determination, and Control Officer. So that's the console responsible for systems the space station uses to know where it is, what direction it's facing, and then keep it where we want it. When I became a flight director, out of 100 flight directors, 19 had been female in NASA history, and a lot of those were, in recent times. My flight director class was 3/4 female. My leadership style has definitely evolved over time. It's taken me some time to figure out how to empower the people on my team to solve problems. As a younger leader, I think it sometimes was easier for me to take a problem, solve it myself, and give the solution back to the team, which might help that moment, but doesn't help us grow as a team on the whole. Whereas I've found new strategies to have the problem solved by my team members and just guide them in that process. The career achievement I'm most proud of so far, just this past December, I led a spacewalk, which meant that I was the flight director on console here while 2 of our astronauts were outside the space station deploying a new solar array. And it was incredible. We had an amazing team here on the ground and in space, and working with that team and getting to lead them was just an honor. I would hope that the impact I could have on McKelvey engineering, either through directly working with students or just through things like this, is to help people realize that they can go do whatever they want. I am extremely lucky to have taken the education I received at WashU and been able to literally get my dream job with it, and I hope people recognize that they can do that too. The word emerging, I take that seriously. To me, it's an obligation that I need to continue to lead that helps propel me to continue to dream big and do things, and the school's faith in me doing that is definitely humbling.
Fiona, thanks for everything you do and for making 9-year-old girls look at that screen and say, wow, I love to do that. Congratulations.
Okay.
Okay, so something we started, I think maybe just last year, I can't remember if we did the year before, was to have a brief panel of our emerging leaders, get them to be able to answer some questions and then any questions you folks might have. So to moderate that panel, I'm thrilled to introduce Associate Dean Chris Kroger. Chris is the Associate Dean Director of Undergraduate Student Services from McKelvey Engineering. And in fact, you're going to be at a banquet sometime soon, aren't you? Or some,
so, yeah.
Yeah, for what?
Which one is it?
Is it 30 years?
Oh, yeah.
Oh yeah,
33 years.
33 years, right, anyway. Chris has been here a long time. And not just does he know, not does he just oversee an entire team that's dedicated to the success of our undergraduates, and that's really what they're dedicated to, is the success of our undergraduates. But Chris has really distinguished himself in terms of thinking about the university, so much so that there's a single award given out every year for distinguished service across the university, the Gloria White Award. And Chris was the recipient of that Gloria White Distinguished Service Award. So Chris, thank you for all you do for the school, and I turn it over to you.
Thank you, sir. Please come forward and take a seat up front. You know, what is so cool is that I remember all 4 of these folks very well. They were undergraduates, and they were incredible individuals and students, and that has only continued forward. Often today now when I look at students, I think to myself, well, this student could be the next Frank or Fiona or Kate or Craig, and because of the wonderful things that they do. Frank, you're on the end here, so we'll start with you. So, what was it, what experiences did you do as a student here that really helped you propel and do what you do today?
Well, I think it would have to start with its sophomore year, co-founding the Engineers Without Borders chapter on campus. And And it was radical at the time. There were a lot of obstacles to start a student group, and including people were wondering in the engineering school, what, we're doing enough research, we're doing it, you're going to distract our professors from this or that. To get the group started took a lot of work, but once the group was started, then you could just see it take off in the minds of my classmates and what we were trying to do on spring break and summer break and winter break, trying to get to places where we could make a difference. And to be honest, I was all in on Engineers Without Borders before I ever had a corporate job or read a mission statement or whatever else. It was, this is what engineering is for. And that experience, traveling with Melanie Osborne to El Salvador and doing other work around campus. After graduation, I went to Guatemala with a classmate to follow up on an Engineers Without Borders project. It really transformed kind of what gets me out of bed in the morning, at what my engineering degree is for, why I'm here, and why I'm doing this.
I still really remember that trip and Melanie coming back and telling stories about it. It was pretty phenomenal. So think back now, if you were in the audience, what advice could we give you that would have helped you? If something come to mind when you were a student, if we would have said it would have been a bigger help?
I mean, it's not my quote, it's another quote, but the future is here, it's just not evenly distributed. We spend so much time, specializing and focusing on the very detailed, specialization of what engineering technology and what new research we can put out. And another aspect is we're really focused on the energy transition, where we're going to have this generation. I'm going to be generous. Even though I graduated 15 years ago, I'm going to say I'm in the same generation as the current students I'm speaking to right now. So in our generation, we have to solve climate change. But hand in hand, if you're going to have an energy transition, you need to have energy access. It's not fair to talk about decarbonizing when the world doesn't have access. And for anyone who doesn't have access, 700 million people in the world don't have access to electricity, roughly 10% of the world. We need to include them in the solutions that we generate. And so for engineers, there's a huge amount of work to be done there.
Thank you. I meet a lot of students who say they care about things, they care about the environment, they care about the underdeveloped world and want to improve life, but there's not a lot that I've met who have really done what you have done and dedicated your entire life towards that goal. And you're passionate about it, you live the mission, you walk the walk. So, thank you.
Thank you so much.
Kate, how you doing?
Great.
So, when you think back to what you gained from here and the variety of activities that you were involved in, classroom, outside the classroom, what really helped you in your career?
So, I think there are a lot of technical skills that I learned during my time here that really helped early on in my career. My very first job in school, my manager said he saw the research that I was doing at WashU, and he said, that's the person I want. But I think beyond that, I think that one of the things that separates WashU's engineering school from some others is an emphasis on really learning how to communicate technical ideas to a broad audience. Because throughout your career, not every single person you're going to interact with, in fact, most of the people you interact with, are not going to have the same technical background or interests that you have. In fact, they're likely going to have a very different role. And like Frank said, you're there to help people. You're there as a support. And so being able to take really complex ideas, break it down in a way that a broad audience can understand, and figure out ways to help them is, I think, something that's unique to my experiences here.
And when you hear the phrase, think like an engineer, what does that mean to you?
Yeah, I think it's a really loaded phrase. I think, in school we're taught to think like an engineer, right? You get a problem set, you look at the givens, you state your assumptions, and then you discuss how you get to your end solution, and it's fairly neat. I think in reality, nothing is ever that clean and that clear. But by thinking like an engineer, you can still kind of apply that framework and that mindset to solve almost any type of problem, and it won't be as neat, and you won't have all of the inputs and all of the givens, but if you can take the information that you have, think about all of the other factors, figure out what your assumptions are, and then help provide a whole bunch of different solutions and even a recommendation on like, this is the best path forward, then you really can be of service to the people around you.
And you certainly have been a lot of service. Thinking about your work with during the COVID time in a hospital like that, think about the number of lives you helped save through your efforts.
No.
And directly or indirectly, but also the families of those lives you saved and the impact that the contributions you made. So thank you.
That's very kind. But, all that we do is we help provide information for the people who are on the ground doing the real care of patients.
Well, as Fiona will tell you, information is kind of important.
It is. I like information.
So thank you. You see a different kind of world and a different kind of leadership take place, which is also very high stakes, which lives are involved, but you've got a lot of people involved in working with a few people up in the air. What qualities, from your perspective, best exemplify great leadership?
Yeah, Kate actually talked about one of the things I think is really important, which is being able to communicate. Being able to take the information that the really smart people who are working for you on your team are developing and then advocate for that information to people who don't have that technical detail. I also want to highlight something that the dean said in his introduction about asking questions. I think one of the most important things I learned in my flight director training was how to ask the question that actually got me the piece of information I needed. And so that ability to craft a question I think is a really key part that makes you an informed leader. And then the last thing I want to highlight is, and it connects to that, is the humility to recognize that you need to ask the questions. I talked a little bit about it in the video. If it's easy to just decide you can solve problems yourself, and there's pretty much no problem that one brain is better at solving than 10, right? Getting more people gets you a better solution. And so recognizing that, yes, I might be the person in the chair, but my job is to make this team successful, and the humility to lead in a way that does that, I think, helps any team, no matter the context.
And looking ahead, knowing what you know, the projects coming up with NASA, what projects really excite you a lot?
I am super excited about Artemis. A lot of you may have seen last Monday we announced the 4 next humans that are going to the moon. They are awesome. It is super cool to see really solid people in that position who look like humanity, right? We're sending the first non-American, the first woman, the first person of color to the moon. And these humans as individuals are just, some people say don't get too close to your heroes because it ruins the facade. I will tell you guys, you can get close to these heroes. They are just awesome humans. So I'm excited to send them around the moon. And then after that, I'm working with SpaceX closely, developing the Starship moon lander so that on Artemis 3 we can put humans, different humans in those 4, but other awesome humans back on the lunar surface. And we're going to do that in the next 5 years. So that's going to be cool.
I remember when I was in grade school, they would roll the black and white TV in for us to watch, and humans on the moon.
Yeah.
And in my mind at the time, the astronauts were like Marvel superheroes. NASA was this amazing place where the smartest people in the world were making all that happen. And the video mentioned that you had this strong interest since middle school.
Yeah.
And that never stopped here, because I remember you going to a competition with your nano satellites to Albuquerque.
Yeah, Dr. Swartout, who I dragged back today, was our advisor for that.
To go to that.
It was super, super cool.
You got some type of $10,000 astronaut scholarship too. So your interest, and then you on the Comet.
Yeah, I flew twice on the Bomber Comet through undergraduate research
For those
programs.
of you who don't know what that is, it's an airplane that goes zero gravity, dropping, and they float in the air. And as a student, that was just amazing to see.
Super. It was really, really cool experiences. Little stepping stones on the path, definitely. Each of those experiences you mentioned.
It's kind of rare to see students live out their passion throughout their life like that. and staying on track. So congratulations.
Thank you.
So we'd love to see more of our students go off and get PhDs and do the things that you do, Craig, and it's hard to get them to do that sometimes. What were the factors that helped you make that decision to go and get a PhD and take an academic path?
Thank you, Dean Kroger, for the chance to be here, and Dean Bob for the invitation to be part of this panel. So yeah, I came to WashU excited to learn, and then the chance to do research here just really put in my head that that's something that is fantastic and what I want to do with my career. So it was an undergraduate research experience in a lab here, led to other experiences through summer programs, and then a senior design program and project with Dr. Jenin that led to interest in graduate school. And I remember thinking that, you know, some of my classmates were burned out, but I really wanted to keep going because I figured if I got a real job, I would never go back. So it's been fantastic to stay in touch with the BME program here under Dr. Sutton's leadership and see how much the program has grown and expanded and continued to be just this powerhouse producing top students, top graduates go off and do wonderful things all over. So the creativity, the chance to answer questions that aren't known in research and not just, you know, the problem set that has one right answer, that's what I really love about the position of research.
And what have you valued most about your educational experience here in the classroom and outside the classroom?
Sure. Yeah, so the WashU engineer is hardworking, they're humble, and they're really interested in making an impact. I think that's the big thing, right? We're not just trying to publish the paper or do the next little incremental step, but make an impact in the world, whether it's globally, out in space, or with the human body and with health. So I think the time management skills here, the chance to interact with faculty one-on-one, the chance to make friendships with other students and staff even, is really fantastic and something that the McKelvey School does well.
Thank you. And I hope you never underestimate the impact that you have on your students, because think about the impact the faculty have had on you and your development. And you're having that same impact and changing lives and encouraging people to take certain paths to change the world. So thank you for doing that. To all of you, each of you, what does this award mean to you, and what impact, legacy-wise, would you like to have with Washington University?
Well, this award is a tremendous honor, and thank you, Dean Kroger, Bobick, and everyone who helped invite us back here. And in terms of what it means to me, I don't know about my esteemed colleagues here, but WashU engineering degree is not easy, and at least it wasn't for me. And to do 4 years worth of a whole lot of effort and kind of contorting my brain into new ways of thinking, broadening my horizons, having the support that I needed to, discover some of the passion of Engineers Without Borders, to apply engineering to the real world, and the confidence, that if I could start a student group here, maybe I could start something else somewhere else, and eventually start a company, and eventually, travel internationally and do the work that I've done. It's incredibly meaningful to have that kind of non-conventional path recognized by WashU. I bounced around a little bit in my career because I kind of was blazing a new trail. There weren't a lot of role models that have taken an engineering degree to the places I've taken it. But my fundamentals are solid. I made it through this program, and I was able to carry it forward. So to be validated in that is incredibly meaningful and humbling. And I certainly hope that the students here maybe can find some inspiration in what I've done with this degree, and be part of this future that we need to create.
Thank you.
To echo what Frank said, it's a huge honor. It's incredibly humbling. And I also want to thank you and Dean Bobick and Allie and her team for coordinating this amazing weekend. And I'm also just going to give a special shout out, in addition to my husband and daughter in the back. In the back are 3 fabulous women who are leaders in their fields as well, who are my Washington roommates. They all traveled from across the country to come here for this, and I think that, that also speaks a lot to, how important WashU has been in my life, not just the engineering school, the university. I think that this award has been like a really nice opportunity to reflect on my previous experiences and where my career has taken me, but right as the name suggests, it's emerging. I'm nowhere near done, and it's given me a good opportunity as well to think about what do I want next. I hope to be a role model for my daughters, but also for female engineers. And for any of the students here who want to see how you can take this technical skill set and apply it to a whole different set of problems and industries, and the opportunities are really endless.
Thank you.
I think I would echo a lot of that. The amazing part about WashU is the people, and I felt really lucky to be a person who was part of that people, right, as an undergraduate in a community that was full of passionate people who were trying to make a difference and who were devoted to learning. And so to be awarded from that group of people is really humbling. I'll echo also emerging as kind of, a threat is the wrong word, right? But it's kind of a poke of like, you're not done. And so I appreciate the faith that WashU has shown in me through this award. It was so influential for me to be a student at WashU, and being able to have another excuse to come back and some exposure to meet some students is really cool. So it's really awesome to be here.
Thank you.
So thank you for the opportunity to be here. I need to thank my family that made a WashU education possible, and especially my wife, who will do things like take a day off of work from her career, and my kids for coming to St. Louis today. Clara and Spencer, thank you. They've been part of this journey that, the academia can be crazy, right? Including moving to France for 5 months last year on a Fulbright for sabbatical, and going to an international school and having their horizons expand as well. So the one thing that I would love to be part of here is to help with the next generation of McKelvey engineers, so that I can be a part of that process in creating the next generation of BMEs in the field. So maybe I can recruit a few of you to my group at some point. I'd love to have you as a grad student or a postdoc eventually, and hope to be just as good a teacher as I had here in St. Louis.
Awesome. Thank you. To stay on schedule, I think we have time for one question. So is there anyone with a burning question that they would like to ask the panel?
So, surprisingly, I'm shocked to hear not one of you mentioned how inspirational the homework assignments are. I don't know, all of you have been very successful. You guys launched your careers very quickly, very early on, and been extremely successful early on. What do you recommend? How do you focus your time as an undergrad? How important is homework versus what you're doing outside of class?
Are you sure you want us to answer that?
I'm also just going to say that I remember your exams and the dynamics and the people puking on the Ferris wheels and very, very, very interesting questions.
I'm really good at talking about it. I'm tenured, say anything you want.
Let the record show I did my homework assignments. But I also did other things. I think what was important for me in college, and I've talked some about the nanosatellite work I got to do, was being able to take the things on the paper and understand what they actually meant in a setting where I could apply them. And so you have to learn the fundamentals, and that means you have to do your homework. My parents are professors too, so I have a lot of people in this audience to whom I have to say you should do your homework. But recognizing that it's probably, there's a trade to be made, and do I spend an extra 3 hours perfecting this last piece of my homework, or do I go have a hands-on experience where I am communicating technically, or I'm putting some wires on a circuit board that will become part of this project? that side really matters too. And so I think for me, just managing the time of, okay, I need to carve out the time to do my homework, but I'm going to do that in a way where I'm not taking away from application experiences, helped me enjoy even my homework more, right? Because I could see how it applied, and kind of got that balance of not just spending all my time doing my homework.
I would also just add, I'm not sure that I ever really found balance as an undergrad and a grad student. It was a lot of work. But for me, what did provide a little bit of balance was being involved in things that were not related to the engineering school. So I was very active in my sorority, and that was a really nice way for me to just kind of still be involved in the community, in the school, and meet lots of people, but it was kind of separate.
Well, I would say in my sophomore year, during the whole process of starting Engineers Without Borders, one of my sophomore roommates turned to me and said, "You're the only person who's actually not here for the school." It felt like I was doing so much extracurricular that it wasn't. And for me, that was kind of a big deal. I almost didn't make it through engineering school. My sophomore year, I was kind of undecided. Physics and calculus, and it was freshman year. The prerequisites to really get into the, I guess, fun parts of engineering took a lot out of me. And I always have kind of thought of myself as kind of a people person. And engineering, for at least the first couple of years, it's all about things and it's not about people. And it was a real challenge for me to make engineering about people. And the homework, unfortunately, is not about people. So it actually took me a couple of years to see past the homework and to see what this kind of stuff could enable in me. And that was the founding of Engineers Without Borders, and then kind of the rest is history. Because what was on the chalkboard wasn't what made me an engineer. What made me an engineer was what we can do together, and how we can be as engineers in a service-driven, a people-serving profession. And so among many extracurricular activities, the Catholic Student Center, some of the folks here are here today. I represented the engineering school in the Student Union Senate for 3 of my 4 years, and was kind of all over campus trying to find a niche for myself. The niche wasn't in engineering initially, and that kind of came later with my involvement, kind of helped ease my way into the school and make this campus a real home for me.
I'm curious to see how a professor will answer this question.
So, being it's quite an experience, and I will say, when I'm an hour into my 75-minute lecture and I see half the class nodding off, I think, all right, what would Guy do in this situation? So it's a fantastic experience to be part of somebody's training, and I think always for us in BME, tying it back to the patients, to understanding the disease process is always important. So the homework's important, understanding the fundamentals is important, but then thinking about how is it going to impact the patient itself is what I try to emphasize, and what I learned about human sequence.
Thank you. All right.
In my mind, exemplify the best of us from the standpoint that, first and foremost, you're decent human beings who take your intelligence and your energy and your efforts and apply that to make a world a better place in your own unique ways. So thank you for that, and congratulations.
Very good. Chris, as always, tremendous job. No, Fiona, it's not a threat. It's not a poke, but it is a challenge, right? The challenge to you, all of you, the challenge to our previous Emerging Leader Awards, and frankly, the challenge to all of us every day here at McKelvey, is to think about the trajectory you're on, think about how you can contribute as much as possible to the world around you, to the people around you, and to the places that matter to you. A colleague, a friend of ours, talks about things you can do for a university, and she talks about time, talent, and treasure. And all of those are ways in which people can give back to their university. And through your inspiration, through your engagement, we will continue to track you, because we want our students, no, not for that reason. We want our well, maybe a little. We want our students to see what is possible. And you know, as you point out, when you're in the weeds, you know, it's 3 a.m. and I don't really understand this equation. And I got to hand it in. And by the way, swim practice is at 5. It's sometimes hard to remember, why am I doing this? And when they get to meet folks like you, then it's easy to remember. So it's been a great afternoon. It's one of my favorite days of the year. One of my toughest parts of my job is following people like this. So I figure out a good way to do that is to invite you for food and beverage. So I invite all of you to join us upstairs for reception. And once again, a round of applause for our awardees.